In this presentation, we're going to look at analyzing functions. Here we go. So consider a function f where the domain is the square of real numbers. So this is the domain here. Okay. And it's essentially a real number squared. Okay. For example, -1 or whatever squared. Now, this is the codomain here. Okay, and the brackets essentially means 0 inclusive is the lower bound of this range, of the domain, codomain, and so it is 0 inclusive, and the upper bound of the codomain is plus infinity. Okay, and here's the actual proper function definition here, or the mathematical formulation of it. So this part here is important. So you have two inputs essentially, x and y, and this is the output. The square root of half of x squared plus y squared. Okay, now the question is, find the range of the function and say if it is surjective. Also, let's a couple of other little questions there. So let's just recap here. This is domain here. Not particularly relevant, or not massively important. Codomain is this part here, and this is the function. But what we want to know is if it is surjective, and if it is surjective, codomain. Sorry, I slightly misspelled. That should be an O there. Is essentially equivalent to range. Okay, that's general idea. So we're going to use the codomain as a sort of general sort of guide for determining the range. And essentially we're just looking at the upper bound and the lower bound. This is the highest possible value of the codomain and the lowest possible value. Well, in the essentially, let's consider the inputs to this function here. Or let's actually write out the specification of it. Half of x squared plus y squared. Well, we have the possible inputs can be real numbers, so we can have -1 as x and -2 as y. But essentially what we have here is we're going to square them. So no matter what real number we put in, we're going to get an x squared. We're going to end up with a positive number, x squared plus y squared. And two positive numbers together is also positive, and if we divide that by 2, add them together and divide it by 2, they are going to be positive. Okay, so no matter, let's undo that. No matter what we have here, we're going to have a positive number. Now, let's get a little bit more strict now about the definition of a positive number. So I'm going to sort of change the positive number as a sort of layman's term sense, but I'm going to be a bit more strict about positive number. So I prefer not to consider 0 as a positive number. So negative, non-negative, okay, would be a better way of putting it, because if you consider what we have up here, the lower bound is 0. So what happens if x is 0 and y is 0? Well, we have x squared plus y squared, 0 squared plus 0 squared, that's 0. And 0 divided by 2 is still 0. And half the square root of that is 0. So the 0 is a possible outcome of this. So actually, where I said positive, really a better word would be non-negative. It accounts for the fact that 0 shouldn't really be considered a positive number. Okay? Now, anyway, what does that mean? So, it means that the range can include 0. And what's the maximum possible value of that? Well, it's plus infinity again. Okay, there's no upper, there's no sort of way of sort of finding the upper value of that. It's some massively high positive number. Anyway, this is the range here. And as we can see, this is the range here, and that is equal to the codomain. So we can say that yes, it is surjective. Okay. Now, that's the main part of it done. By the way, there's also surjective and injective is also called one-to-one and onto. We're going to leave that for another time. What I'm going to do is sort of calculate the f of 1 over the square root of 2, 1 over square root of 2. F of this 1 over the square root of 2. 1 over the square root of 2. This question is straightforward enough. That is equal to the square root of half of 1 over the square root of 2 squared plus, actually another bracket there would go becoming useful, 1 over the square root of 2 squared. And what is that equal to? Well, that's equal to 1 over square root of 2 squared is a half. So it's equal to the square root of 1 half of a half plus a half. Okay. What's a half plus a half? That's just 1. So we could just cancel that out. So what we end up with is the square root of 1 half. Again, nothing particularly tricky there. So prove that f is not injective by providing a counterexample. Well, the idea of injective is that if you know each input has its own unique output, and each output of the function has its own unique input. A way of sort of proving that it is not injective is to have two different inputs to the sets of inputs to the function and show that they have the same output. So what we could do here, very simple example, is we could have the first example, let's call this example A. F of, let's say, 0 and 1. That will give us the square root of half x squared 0 squared plus 1 squared. That's just same thing again as from the last example. Okay. A second example. Now, the fact that or x and y, I'm going to use the same numbers in reverse, that is still makes it an entirely different input. It's a different sort of part of the domain from example A. 1, 0, f of 1, 0 and f of 0, 1 are not the same. We actually get the same number there. 1 over the square root of 2. So you can see pretty clearly that both of these values are equal to each other. And that means that it's not injective. We have two inputs that yield the same output of the function. So, not injective. Okay, that's that.